Hi, my name is Pardi,
And I'm Andrea Turner.
and we work together on the Operating Systems Process Queue and Shell project.
This is our video demonstration. First, we will show you our project passing all of the automated tests.
As you can see, the first unit tests it goes through are the process ones. In process, we were able to learn and review some knowledge from systems programming, such as system calls of fork and exec.
Next, it goes through the unit tests. And when writing queue, we revisited how to use pointers to manipulate queues and how to iterate through singly linked lists.
We also learned a lot of great knowledge about error checking throughout the whole program.
We also were able to practice using GitHub in a collaborative way by both working on the same repository. We had to review how to use Git push and Git pull together so that we didn't have any merge conflicts, and we're both able to successfully update our GitHub repository.
According to our knowledge, our program has no quirks and it has no unresolved issues. As you can see, it's gone through the FIFO test and the round robin tests.
Next in our video, we'll discuss what we learned about round robin and FIFO. Now we're going to show you running our program with manual input. First, we're going to run our program in regular mode, which means that we'll be using FIFO. First, we add a process to the queue, and next we add a second process to the queue. As you can see, one of the programs is in the waiting queue and the other is in the running queue. Now, one of the programs has finished and the other one is still in the running queue. Finally, both programs have moved to the finished queue. As you can see, our program displays both the turnaround and the response time. Next, we're going to switch to run our program in round robin mode. This means that the processor will switch between running different processes. First, we'll add a process to our waiting queue. Next, we'll add another process to our waiting queue. First, one of the programs is in the waiting queue and the other is in the running queue. As we check the status, the programs will switch back and forth between being in the waiting queue and the running queue. As you can see now, one of the processes has finished running and the other is still in the running queue. Finally, both processes have finished and both are in the finished queue.
Now we're going to discuss what we learned and the differences we found between round robin and FIFO. At the top, we ran round robin, and at the bottom, we ran FIFO. For both, we added 2 processes to the queue of a bin work sum with duration 10. Here's the turnaround and response time for round robin, and here's the turnaround and response time for FIFO.
As you can see, using round robin, we have a slower turnaround time, but a much faster response time. Using FIFO, we have a faster turnaround time, but a slower response time. As we learned in class, this is because using round robin, the processor switches back and forth between executing different processes. This means that the processor gets to start executing each process quicker, resulting in a faster response time, but it ultimately takes longer for both processes to finish, resulting in a slower turnaround time.
Thank you so much for watching our video. We hope you enjoyed.